Hello and welcome to the Data Engineering Podcast, the show about modern data management. Atlan is the metadata hub for your data ecosystem. Instead of locking your metadata into a new silo, unleash its transformative potential with Atlan's active metadata capabilities. Push information about data freshness and quality to your business intelligence, automatically scale up and down your warehouse based on usage patterns, and let the bots answer those questions in Slack so that the humans can focus on delivering real value. Go to dataengineeringpodcast.com/Atlan today, that's ATLAN, to learn more about how Atlan's active metadata platform is helping pioneering data teams like Postman, Plaid, WeWork, and Unilever achieve extraordinary things with metadata. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With their new managed database service, you can launch a production-ready MySQL, Postgres, or MongoDB cluster in minutes, with automated backups, 40 gigabit connections from your application hosts, and high-throughput SSDs. Go to dataengineeringpodcast.com/Linode today and get a $100 credit to launch a database, create a Kubernetes cluster, or take advantage of all of their other services. And don't forget to thank them for their continued support of this show. Your host is Tobias Macey, and today I'm interviewing Wes McKinney about his work at Voltron Data and on the Arrow project and its surrounding ecosystem. So, Wes, can you start by introducing yourself?
Yeah, sure. Thanks for having me. I'm Wes McKinney. Many people know me as the creator of the Python Pandas project. Started almost 15 years ago, but over the last 7 years, I've been primarily focused on the Apache Arrow project and the surrounding open source ecosystem. More recently, I'm the CTO and co-founder of Voltron Data, a data analytics startup where we are offering enterprise support and services around Apache Arrow and doing a substantial amount of open source development in the ecosystem.
And do you remember how you first got started working in data?
I've told the story many times, but I was working in quantitative finance right out of college. I had a math degree and turned out that I thought I was going to be doing math and solving partial differential equations and that sort of thing, but it turned out that I was mostly doing data analysis and writing SQL queries and using data frames and things like that. And so I started to get interested in the tools for doing data analysis because I wanted to make myself more productive, because I found my job to be quite tedious and working with data to be much more difficult than I thought it should be. And so for me, it started out as a personal challenge to see if I could create tools for myself to enhance my productivity. And I found that I enjoyed building tools, and I, become very passionate about open source software. And, I love working in the community and building projects and helping progress happen faster.
In terms of the Voltron Data business and the kind of focus of it, I'm wondering if you can give some of the overview and some of the story behind how it came to be.
The Apache Arrow project started, we got the initial group of developers together in 2015 to start the project, formally launched it as a top-level project in the Apache Software Foundation in 2016. And we set about, growing the different layers of the stack. And as time went by, we started to observe, more general trends in the interplay between programming languages, data storage, data access, and kind of the data analytics stack, and the role of, the evolution of hardware and computing hardware. So in particular, things like graphics cards, GPUs, FPGAs, and custom silicon. There were many different groups of developers working on different layers of the stack in and around the Apache Arrow ecosystem. We saw an opportunity to build a unified computing company, bringing together, several of those groups of people. So respectively, myself and my team from Ursa Labs, which became Ursa Computing, group of leadership from the Rapids project, which had been started at NVIDIA, and the Blazing SQL project, which is a SQL engine built on top of Rapids. So we reasoned that we could build a more integrated and more successful company, working together under one roof than trying to grow our different slices of the pie, so to speak. So that's how the company came together beginning of last year, to build a large team. Thankfully, we were able to assemble quite a bit of investor capital before the market turned south earlier this year. We've been really just heads down building the last year and a half, which has been really, really exciting.
One of the, I guess, kind of meta notes that I'm curious about is how you settled on the name of Voltron as the company name and how often people wonder what that is in reference to.
We like the name Voltron Data. We wanted to evoke, the feeling of, what we were building being something that is, the whole is greater than the sum of its parts. And, I think the mission of the company, kind of the heart or the soul of the company, is making the modern data analytics stack more modular and composable to make it easier for developers and users of analytics or data engineering tools to unlock the value of modern hardware and to take advantage of advances in computing capabilities, as they become available. And so I think we've seen, in the world of machine learning and AI, deep learning training, machine learning training, that sort of thing, we've seen, significant change to the technology landscape through use of hardware acceleration through GPUs, and now we're seeing TPUs and custom chips for accelerating machine learning. There's the same kind of innovation and improvements in computing efficiency can be brought to the other layers of the data processing stack, analytics, machine learning preprocessing, ETL. We're really focused on improving the, protocols and standards, like the fundamental technologies that enable that kind of modularity and composability at the kind of, language, data, and hardware level. And so if, developers observe, the work that we're doing in not only in Apache Arrow, but in some of the surrounding projects like Substrate and IBIS, which we can dig more into in this podcast, you can see how we're working on, really hardening like these interfaces and protocols between the different layers of the stack to make it easier for developers to, swap out components and develop a more kind of framework agnostic or engine agnostic fashion. If that makes sense.
As far as the broader vision of Arrow, it has these immediate benefits of being able to operate as an interchange format between different languages and runtimes and frameworks. And it has been growing in terms of its scope and its capabilities. And I'm curious if you have any overarching vision for Arrow and its potential impact on the broader data ecosystem and some of the ways that the work that you're doing at Voltron is aimed at helping to bring forth the realization of that vision.
Going back 6-7 years when we started the Arrow project, I did always have the aspiration of building a more modern computing foundation for data frames and tabular data processing. And so for me, like expanding the scope of, what we call Apache Arrow has always been, something that I've been really motivated to do. But when we started the project, we had to start small. Like, can we, as a community, come to an agreement around how we represent tabular data in a framework and language agnostic fashion, such that we can achieve this concept of like a universal data frame, which can be used portably across computing frameworks, programming languages, different processing environments, so that we can have a basis for beginning to think about that kind of, frictionless modularity and composability at the data level. Once we did that, we had to move on to building the other layers of the stack, which are necessary to build Arrow native applications. And so that's, the data serialization, building RPC for moving around data efficiently in a distributed system. More recently, we've been looking at the protocols and interfaces for interacting with databases in an Arrow native way. And so we've got sub-projects which are specifically focused on integrating Arrow more natively into database systems. So we make it easier to push Arrow-based data sets in and out of databases. The other dimension of not only having a data format that is a universal data format, protocols and interfaces for moving it around, protocols for connecting systems together in an Arrow native way, but we also needed to build computing engines to process Arrow data so that we embed into different systems to do, data cleaning, data preparation, feature engineering for machine learning, analytics, all those things that you would do with a, SQL engine or a data frame library, that sort of thing. And so as time has shifted, the work in the Arrow project has moved away from building these fundamental protocols and interfaces to more of the, modular embeddable compute engine development, which has been really, really exciting to see.
One of the initial motivations for Arrow was to cut down on some of the inefficiencies of that data interchange. I think one of the most notable examples is using the PySpark library to interact with a Spark runtime and having to serialize and deserialize the data in between those interfaces, as well as having to translate between the representations of information between Java and Python. And I'm wondering if you can give an overview of the kind of types and scope of impact on engineering productivity and compute efficiency that the Arrow project and the kind of growth thereof is intended to address.
I think the Spark example is a really motivating one because that was one of the first practical problems that we focused on solving with the Arrow project was the problem of making Python on Spark a lot faster. And so if you look at, as a user using PySpark versus using the Spark Java or Spark Scala APIs, there was a significant performance penalty in using Python whenever you wanted to extend Spark with custom Python code that might use pandas or might use scikit-learn or something else in Python ecosystem. So by defining a column-oriented data format which could be constructed on the JVM side inside the Spark runtime and then sent over to the Python side for executing custom code, by having that not only a more efficient data format to move across, but also something that could be interacted with very cheaply on both sides without having additional conversion or serialization, we were able to, this was my colleagues at Two Sigma and collaborators at IBM, we were able to make custom code running in PySpark 10 to 100 times faster in some cases. Now, of course, there's many workloads in Spark which have shifted to use the Spark data frame API where under the hood, Python code, Java code, Scala code, it gets translated into effectively a SQL query, which gets run by Spark SQL. And so there's no need for data to ever be transferred into Python. But there still are plenty of use cases where it's necessary to run custom code. And Spark is used in many cases as a convenience layer for doing parallel and distributed computing with Python. But users shouldn't have to pay an enormous penalty to have that privilege. And so Arrow has really helped in reducing the overhead, the impedance between those systems and in those cases. That being said, Spark and Spark SQL are, systems that have been around for a long time, but Spark SQL was built before Arrow existed. And so internally, it is not, an Arrow native system, so to speak. So it represents the data that flows around Spark or inside Spark SQL in a data format that is not the same as the Arrow format. And so I think what's really interesting for thinking about the future is having Spark-like distributed systems for large-scale tabular data processing that are fully Arrow native end-to-end. And so you have the ability to extend those systems with custom code written in principle in any programming language that knows about Arrow. And so we enable much more, kind of fair and kind of consistent polyglot experience across the stack where no programming language is being unfairly penalized, but through as a result of having to do expensive data serialization at the programming language boundary.
Because of the fact that you aren't paying a penalty by virtue of the language or the runtime that you're choosing, I'm curious how you see that influence the decisions that engineering teams make as to how they want to compose their stack and compose their analyses, and some of the ways that reflects in terms of the skill sets that are necessary to be able to build and maintain these analytical systems.
For me, what's exciting and motivating is for the users to have the choice and being able to choose the programming language and the types of APIs and user interfaces that make most sense for the systems that they are building, and to have more kind of a more natural, let's call it language integrated querying capability So I think part of the challenge that we have as system developers is to make it easier for the programming language interfaces to evolve and innovate independently from the backend compute engines. And so, our goal with what we've been building in Arrow is to put, very fast, Arrow native data processing to make that available in a form factor where it can go everywhere. So it can be, deployed in, heavily resource constrained environments. We're having, very low latency, efficient tabular data processing with the in process is highly desirable, but that we can also, using the same APIs and user interfaces that we use to do local small scale computing at the edge, so to speak, that we can build descriptions of our workloads or our data transformations in a form where they can be serialized and sent into, large clusters for, doing larger scale data processing. And so that's one of the reasons that we've been investing pretty heavily in this new project called Substrate, which is building a intermediate representation for data analytics operations that can be used to connect user interfaces and computing engines on the back end. So you can think about Substrate as being like something that's, lower level than SQL and can be used to represent, tabular data or data frame operations that go outside of what is expressible in SQL. And so it's our hope that by hardening that interface and making it straightforward for engine builders, compute engine builders, to focus on building a substrate interface to their engine. And so then from the API developer standpoint, the user interface developer building Python libraries or Go libraries or Java libraries or Rust libraries, at the user interface layer, we can just focus on generating substrate rather than having to think about, well, how do I build an interface or an integration with a particular computing engine? Because then whenever there's a new computing engine that you want to take use of, maybe to accelerate some part of your data processing workload, you've got to build a new interface to that engine. And so by reducing the surface area of the problem to let's just think about the world in terms of this substrate intermediate representation, that makes it so much easier for us as API developers to build the user experience because we just have this like one intermediate representation to generate. And then on the back end, the engines can decide how to most efficiently execute the substrate.
Are you struggling with broken pipelines, stale dashboards, missing data? If this resonates with you, you're not alone. Data engineers struggling with unreliable data need look no further than Monte Carlo, the leading end-to-end data observability platform. Trusted by the teams at Fox, JetBlue, and PagerDuty, Monte Carlo solves the costly problem of broken data pipelines. Monte Carlo monitors and alerts for data issues across your data warehouses, data lakes, dbt models, Airflow jobs, and business intelligence tools, reducing time to detection and resolution from weeks to just minutes. Monte Carlo also gives you a holistic picture of data health with automatic end-to-end lineage from ingestion to the BI layer directly out of the box. Start trusting your data with Monte Carlo today. Go to dataengineeringpodcast.com/Monte Carlo to learn more. As far as the overall scope of the Arrow project itself and what is actually contained within the code repository and also the growth of the broader ecosystem around it, they have definitely grown substantially, and I think the most recent release of Arrow right now is version 10, so definitely a lot of development happening there. And I'm wondering if you can give an overview of the current set of capabilities and the, features that are targeted with Arrow and the related projects beyond just that in-memory columnar data representation.
The way that we describe the project these days is we describe the Arrow project as being a multi-language toolbox for building analytical data processing systems. And one important part of the project is the specification and the implementations of the Arrow columnar data format. From there, there's a whole set of different software components which enable you to do things with the Arrow data formats. That includes data serialization, inter-process communication, remote procedure calls, so building services that need to send and receive Arrow data. So there's a framework called Flight for building Arrow native data services. We've started building some database middlewares for integrating Arrow into database systems. So there's a SQL database protocol project called Flight SQL, which provides basically a wire protocol for talking to SQL databases over gRPC using the Flight framework. Another project called ADBC, which is a standardized API for database drivers to provide Arrow native data access. So it's kind of orthogonal to Flight SQL. So it has nothing to do with the data protocol or the wire protocol. It's more about having a standardized API for inserting and selecting Arrow datasets from SQL-based systems. We've got compute engines. So there's multiple computing engine projects. There's the Acero C++ compute engine. There's the Rust Data Fusion compute engine. So there's kind of the, kind of embeddable compute engines in multiple programming languages designed for different use cases. It's an increasingly diverse and federated community of sub-projects. So not just the core 10.0 Arrow. Probably if you go to Apache/Arrow on GitHub, you'll see a large, very large polyglot Git repository. But we've grown several other repositories that house a number of the Rust sub-projects, as well as the Julia Arrow project lives in its own repository nowadays as well. And so we have some support for around a dozen programming languages. And within each programming language, we have, a stack of libraries which are there to make it possible for you to build systems that use the Arrow format or connect to other systems that use Arrow. Of course, some of those libraries are in different levels of maturity. So the Rust libraries, the C++ libraries are generally the most featureful and mature, but we're growing an increasing, amount of support in Go and Java. Initially the project started out, it was just C++ and Java, but has expanded significantly since then. It can be a little bit difficult for a newcomer to navigate, but I think the community has around 1,000 developers, maybe around 1,000 different people have contributed to the project over the last 7 years. So the developer community, we've done a good job, or we've put in a lot of effort, I should say, to make the project accessible to new contributors. So that's through developer documentation and efforts to engage and grow the open source community around it. So it's not just a small, insular group of developers building all of these things, but that we're actively trying to make the developer community larger to share the burden of maintaining all of these different software components that have to be, have to have bug fixes and security fixes and make releases periodically.
Digging more into the implementation of the Arrow project, I'm wondering if you can talk through the actual architecture of the code and some of the ways that you're able to validate conformance with the specification across those multiple different languages that are implementing an interface to it.
As I was saying, the project is fairly federated in the sense that the different sub-projects, their set of features and what the developers are focusing on at any given time, they evolve somewhat independently of each other, but there is the commonality of the Arrow memory format and the protocols and interfaces for interoperability. So one of the first things we did when we started the project was establish a procedure for integration testing between implementations. So for example, in C++, we have a set of C++ classes and different tools for dealing with memory allocation and construction of Arrow tabular in-memory data. And we have a similar set of classes and interfaces in Java, and we needed to define a procedure for a Java application and a C++ application to determine that they understand each other's data. That you say, here's my Arrow data. Do you agree that what I think the data is the same as what you think it is? And so we devised a test harness where we generate a point of truth version of the data set in JSON. Both applications, the integration test harness parses that JSON, constructs the corresponding Arrow version of that, and then compares that to the binary kind of serialized representation of the Arrow data set to determine whether it is identical. So that enabled us to show compatibility between the different implementations. So that integration test harness has grown, to encompass several implementations. And so a new implementation of Arrow, that's the first target for showing compatibility, is participating in those integration tests. But, within the integration tests have expanded to include other things like Flight, which is RPC framework built on top of gRPC for building data services that send and receive arrows. So there's a set of integration tests for those. That's how the main way that we verify interoperability or that implementations are doing the same thing. But within the different programming languages, like the architecture of the projects has evolved fairly independently. There's a different extent to which the implementations rely on external libraries for solving certain problems. So for example, in C++, we've been developing a sub-project called Datasets API or Datasets framework for a number of years, where we enable users to interact with large datasets that are spread across, for example, partition directories of Parquet files in S3. And within the project, we've had to build a C++ interface to the S3 API. We developed the Parquet C++ interface. There's a lot of supporting code for dealing with, asynchronous interactions with remote data sets that we've had to develop. But if you go and look at Rust or Java, the libraries for doing these same sorts of things, there's a different level of, reliance on external libraries. Rust uses more external libraries for some of the things where we've had to develop, home grow some libraries and tools within C++ because there weren't off-the-shelf libraries available. So in general, our mantra is providing a batteries included experience for developers. And so we think about just thinking from the mindset of somebody doing data engineering or building an analytics stack. And we think about what problems is that developer or that user going to need to solve. And so rather than, leaving developers to cobble together solutions, would rather that there be good out of the box solution for some of these run of the mill, everyday, data engineering workflows. So for example, anything having to do with interacting with a large Parquet data set in cloud storage, we want to make that really easy for a developer and for using Arrow to be the fastest, most efficient way to build their system.
And you mentioned with the Substrate project, one of your efforts to reduce the level of effort necessary to be able to add Arrow's capabilities and benefits to the end user experience and being able to integrate with different components of a potential data stack. And I'm curious, with that in mind, but also with some of the other projects that you mentioned, how you think about balancing the desire to be able to move fast and expand the reach and capabilities of Arrow with the need to wait for some of these other products and frameworks and projects to actually do the work of integrating with Arrow and maybe the Substrate project, and some of the ways that you're collaborating with and maybe incentivizing some of these other engines and runtimes to do that work.
As a company, Voltron Data, I think we're lucky to be in a position where we can help accelerate some of this work, like the adoption and integration work. We've been pursuing that through our enterprise subscription program, which is basically an Arrow development and support partnership. So working with companies that are building on Arrow. We've also made some strategic partnerships with projects that are outside of the Arrow ecosystem where we want to invest in Arrow ecosystem integration. So two examples are DuckDB and Velox, which is a new project started by Meta. And so we reason that, there are other developers working on other projects that are, part of this greater vision of building a more modular and composable data analytics stack. Arrow has become a central, key part of that by providing this language agnostic, sort of, let's call it a data fabric for connecting systems and computing on. And so by making it, straightforward for, computing engines like DuckDB or Velox to connect to other systems which use Arrow, that's in everybody's best interest, making it easier for user interfaces. So for example, we've for many years, like we've been building this project IBIS, which provides a scale-independent data frame API, engine-independent data frame API for Python, building an interface between that and Substrate, and then working on Substrate interfaces to these different compute engines. So we make it easy to generate Substrate once and then execute it in any of these different computing backends. So we enable engine choice for the developer. We've been making, over the last year and a half since we started the company, we've been growing our support program, working with customers there, working on partnerships around, areas of mutual interest in hardening and growing the Arrow ecosystem and improving these, standards and protocols for interoperability so that we, can accelerate towards this more kind of modular computing stack for building large-scale data analytics systems.
Another interesting aspect of what you're offering with Arrow is that it is very optimized for tabular data, which is a substantial portion of what people are trying to perform analysis on. But with the growth of machine learning and more scalable and capable compute frameworks, there has been an increase in usage of other formats of data, whether that's unstructured data such as binaries or images or videos or semi-structured or document style data or even multidimensional data. And I'm wondering how you see the role of Arrow in that avenue of either being able to accommodate some of those other different data types or being able to cooperate with runtimes that are trying to maybe enrich either those unstructured data assets with tabular information or, enrich tabular information with metadata from those unstructured assets?
It's a great question. I mean, it's true that, columnar tabular data processing is the bread and butter of many systems. And a lot of the advances in computing efficiency have come through, better use of SIMD instructions, just better, utilization of modern CPUs. And Arrow definitely was designed to enable that, enable, more efficient vectorized data processing. It's also facilitated use of GPUs and has been used productively to do accelerated processing on GPUs and FPGAs. But there are these other types of data that are non-tabular. And so one thing that we've seen is embedding unstructured data in Arrow data structures, so images or text, and doing building I guess you could describe it as a hybrid structure. It's like a table that contains unstructured data. Just to give an example, so, my former co-founder, early Pandas developer, Chang Shi, has got a new project called Lance, which is a computer vision stack that is Arrow native that enables, training and model scoring on image data sets that are all represented as kind of Arrow native in an Arrow native fashion and stored out in storage as Parquet files. You can use DuckDB as an engine to deal with large image data sets. And so the image scoring functions, training and scoring have to be represented as user-defined functions, which get run against these images, which are embedded in Arrow tabular data structures. So we've seen, successful use of successful, hybrid structured, unstructured data sets. That being said, Arrow is not going to be a fit for everything. There's workloads where fundamentally you're dealing with a large, very large tensor. So you could have an Arrow data set that has a column of where every cell in the column is a tensor. And we've seen people do that. But Arrow is not going to be a fit for 100% of use cases. That's just the nature of the beast. Not everything is a table.
Data engineers don't enjoy writing, maintaining, and modifying ETL pipelines all day, every day. Especially once they realized that 90% of all major data sources like Google Analytics, Salesforce, AdWords, Facebook, and spreadsheets are already available as plug-and-play connectors with reliable, intuitive SaaS solutions. Hevo Data is a highly reliable and intuitive data pipeline platform used by data engineers from over 40 countries to set up and run low-latency ELT pipelines with zero maintenance. Boasting more than 150 out-of-the-box connectors that can be set up in minutes, Hevo also allows you to monitor and control your pipelines. You get real-time data flow visibility with fail-safe mechanisms and alerts if anything breaks. Preload transformations and auto-schema mapping precisely control how data lands in your destination. models and workflows to transform data for analytics, and reverse ETL capability to move the transformed data back to your business software to inspire timely action. All of this, plus its transparent pricing and 24/7 live support, makes it consistently voted by users as the leader in the data pipeline category on review platforms like G2. Go to dataengineeringpodcast.com/HevoData today and sign up for a free 14-day trial that also comes with 24/7 support. As far as the business model of Voltron Data, you mentioned that you are support focused, and I'm curious if you can just talk through some of the ways that you think about working with and on the Arrow ecosystem and being able to build a viable and scalable business. And also, because of the fact that a significant portion of your work is focused on Arrow, how that translates into the way that you think about the marketing and customer education about what you're doing.
We have been spending a lot of time and energy on customer education and developer relations, documentation, generating, if you look at our website, voltrondata.com, like we've been putting out a pretty steady cadence of content to help with educating the customer, user base, I guess would be more accurate, user base about different layers of Arrow and other projects in the quote unquote, Arrow cinematic universe, I would say. We've also been running kind of Arrow-oriented conference called the Data Thread. So we had our first back in June. We had an amazing, set of talks around showcasing the work of the community, Arrow users and the kinds of things that they're building, the systems that they're building and solutions. We have another edition of the Data Thread 2023 in February. Very excited about that. As far as our business model and the company, in the short term, we're really focused on hardening some of these fundamental technologies, which we think are going to power the data analytics, machine learning, pre-processing, data engineering stack for the coming decade or two. So things like, as we've been discussing, things like Substrate, core Apache Arrow itself, and some of the user interface layer projects like IBIS. Those are essential building blocks for enterprises globally to become more Arrow native. That's been our primary focus, educating the world about how to take advantage of the work that's happening in the Arrow ecosystem, hardening these fundamental projects, working with partners to accelerate adoption and integration of Arrow, and supporting large enterprises that are building on Arrow through our our enterprise subscription program. So in the short term, that's our focus. We have raised a significant amount of venture capital, and so we need to build a large scalable business, and we look forward to doing that over the coming years. But we're surfing on a very big wave that is disrupting and changing the landscape of data systems, and so our strategy right now is oriented at accelerating the growth and the size and speed of that wave.
In your work of helping to create the Arrow project, and now your focus on growing and expanding its capabilities in the surrounding ecosystem and working with your customers on these support capabilities, what are some of the most interesting or innovative or unexpected ways that you've seen the Arrow project and its related ecosystem applied?
I would say there hasn't been anything super surprising, but I think what's been really interesting is seeing how the early adopters, I think there's plenty of companies and developers, users who are in the mode of being Arrow curious. They've learned about the project, they've seen content over the last several years, they've seen the growing trends, use and people talking about the project. But then you have companies that have essentially already adopted the Arrow religion, so to speak, and have spent 2-3 years or more building systems that are Arrow native, and to see the business impact of that in terms of lower resource utilization, systems that are more interoperable, that have just better efficiency, better performance, lower latency. And I think there's this system turnover problem where companies are replacing their last generation of internal systems that they've built with new systems that are using Arrow. And so there's a certain sense of loss. There was many, developer years of time spent building systems, 7 years ago or 10 years ago. And so now there's this activation energy of building new systems, which are built with this new, more efficient computing stack. But once these systems start to come together and the business starts seeing, a return on that investment, it's really very exciting to see people's, computing or data platforms, data infrastructure become a great deal simpler and more efficient. It's just really validating to me, having spent such a large, fraction of my life working on this project, to see the dream of the Arrow project and its potential in large-scale data platforms become a reality.
In your own work of building this business and helping to create this project and grow it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
I mean, I would say that, building large open source projects that become depended on by a large fraction of the ecosystem is always very difficult. So I have spent, I think the early bootstrapping of the Arrow project was definitely not easy, required a lot of personal and professional sacrifices on my part. And so I was lucky to have some passionate true believers supporting the work. So for example, folks over at Two Sigma who employed me, and then also were supporters of Ursa Labs for a couple of years before we became Voltron Data. Folks at RStudio who really wanted to, RStudio, which is now Posit, who saw the potential for building a more polyglot data science stack. And so I think the lessons learned are that relationships really matter. It's not just about writing code and pushing code to GitHub. Like, the social dimension of building these types of projects is the most difficult, but also the most important if your goal is to build something that has large scope and that you want to be sustainable over a long period of time. We still have, social and sustainability challenges in the Arrow projects. Like, we're Voltron Data, we're taking on a large amount of maintenance and systems burden supporting the Arrow project, which has been, great in the sense that we're pumping out releases, like we're improving the CI/CD infrastructure. Our testing and continuous delivery for the project is better than ever. But then, other people in the open source project would be justifiably concerned about, can we count on Voltron Data to be around and providing this level of support for forever? So there's a justifiable suspicion about companies being involved and large companies being involved in open source projects. But I think, our goal is to always do right by the community. I've always been very, very community minded in thinking about building these projects. So it's been interesting and challenging and stressful at times, but also very rewarding. So, ultimately, like, we see this as the Arrow project as being an agent of change and progress in the open source ecosystem. So we're excited to keep rolling the ball forward and supporting growth of the ecosystem and making sure that, the developers and the users can be successful building on this new computing stack.
Given the fact that Arrow isn't even necessarily the kind of end user selected utility, this question might be nonsensical, but what are the cases where Arrow or its related projects might be the wrong choice?
I think a question that we answer a lot is, Arrow as a storage format, or Arrow as a format for data warehousing. And Arrow is not designed to be a replacement for a competitor with, or a replacement for Parquet, for example. And so, sometimes people do come to the project thinking like, oh, I've heard about Arrow. It's a data format, right? So can I, use it to build my data warehouse or build my data lake? And so, occasionally there's, some confusion around purpose of the project. But I think as we've improved, our developer content and helping folks understand about how, we're building this companion technology to storage systems like, file formats like Parquet, and, large scale metadata management, large scale data set systems like Iceberg. I think that's becoming more clear to users. And certainly, like, there's people doing data engineering or, machine learning that is primarily dealing with, text or unstructured data. And some of those instances, Arrow may not provide a lot of value depending on the nature of the work. But fortunately, a lot of the data that's processed in the world is fundamentally tabular, or at least representable in a tabular format. Most, data generated by modern web applications, mobile applications, can be, represented and processed in a tabular format. And so even though, we don't strive to be all things to all people, there's a large fraction of, data analytics or data engineering where Arrow is a relevant technology that can make things, faster, simpler, more efficient.
As you continue to build and iterate on the Arrow project and invest in that ecosystem and help to grow the degree of integrations that are available, what are some of the things you have planned for the near to medium term, or any projects that you're excited to dig into?
Right now, I'm pretty, we talked a lot about Substrate. I'm very pumped about that. Another, project that I'm really excited about is we've got this effort in Arrow called Nano Arrow, which is building a small implementation of the Arrow format and protocol for embedded use. So if you have a system like a database or, like a microservice or, it could be really anything where you want to add the ability to send and receive Arrow data, but you don't want to take on new library dependencies. This is a project that can be, dropped in and copied into a project in principle in any programming language, as long as you have C, the ability to call C code. And so we think that will help expand the adoption of Arrow into places where it has not reached yet. We're pretty excited about that project, Nano Arrow. Also really excited about ADBC, like the standardized database API, to be used alongside existing JDBC and ODBC interfaces for talking to databases. I think I've always had the desire to make it easier to talk to databases and for applications and users to not have to write so much custom code to just get data in and out of SQL databases. And so I think that the ADBC effort gives us a path to, making that a reality so that we can just think about tables and data frames and not so much about, how do I translate between this database's wire protocol and my, data frame, data structure. Because God knows, I've written and, folks in all of these ecosystems, we've all written a ton of code just dealing with converting between data formats. And so I'm looking forward to a day when we won't have to think about that. We'll have written some of our last data connectors and we can just think about Arrow, and that will make our lives a lot easier.
It's such a great experience for new programmers to have to figure out how to reconstitute the data that they get back from the database with the column names and make sure that they're matched up properly. You're going to rob them of that experience?
That's right. I get that it's it's like a code kata. It's like almost a rite of passage to have to write converters between, the data that comes out of the database and your application. But, I think we've reached a point where I think our efforts as programmers would be best reserved for other challenges.
Absolutely. Yeah, no, I don't think anyone will miss having to go through that exercise. All right. Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as the final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
I'm not totally sure about this, but I think, we're still in a state of learning and change when it comes to how best to build and manage very large data lakes. I'm really hopeful about Apache Iceberg, which came out of Netflix and is one of the next generation approaches for large scale data set management. I think that the sooner that we can settle on standards for scalable open data warehousing, so to speak, I think that makes things for someone like me who's more focused on computing engines and user interfaces, how we get access to the data, how we store and manage the data is less of a moving target. And so the world becomes increasingly standardized on Iceberg, for example, in file formats like Parquet, then that simplifies the problem for the engine and user interface developers to make an end-to-end stack for developers, where the choices are much more straightforward and there's less fragmentation and waste in the stack.
Well, thank you very much for taking the time today to join me and share the work that you're doing at Voltron Data and your experience on working on the Arrow project and helping to illuminate some of the ways that it is being used in the surrounding projects and its growth in the ecosystem. So I appreciate all of the time and energy that you and the other members of the Voltron Data and the Arrow teams are doing. So thank you again for your efforts there, and I hope you enjoy the rest of your day.
Thanks for having me.
Thank you for listening.
Don't forget to check out our other shows, Podcast.init, which covers the Python language, its community, and the innovative ways it is being used, and the Machine Learning Podcast, which helps you go from idea to production with machine learning. Visit the site at dataengineeringpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at dataengineeringpodcast.com with your story. And to help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.